Hello everyone, and welcome back to another R tutorial video. And in this video I want to walk through how we can edit the appearance of layers in tmap with some specific code examples. So if you remember in our previous video, which I encourage you to watch if you haven't already, we went through these 6 different parameters that you're commonly going to see throughout the tmap functions that allow you to edit appearance. And we talked about color, width of line, line type, the size of point, the shape of point, and then alpha, which controlled how transparent a color was. So what I want to do now is I want to just walk through a couple quick examples of how we actually implement these things in code. So I'm going to reload the New Haven dataset, and again, if you're unfamiliar with this, it gives you I think 8 or so different spatial data sets to work with. And we're going to start off with the blocks data set to talk about color and alpha. So we're going to make a map underscore block, and we're going to always call in tm shape first. And this again tells you what data that you need to use, and we want to call in blocks. Blocks. So if we run this, you'll see we don't get an error, but we haven't actually done anything yet. We have to also tell it what type of geometry that we want to use. And so what I would like to do is I would like to actually do border, so tm underscore borders. And what you'll see here is if you pay close attention, this contextual pop-up shows up, and it says that we have access to the call, line width, and line type, and alpha. So we can really tweak all 4 of those parameters in this case. So if we do call equals, let's do blue. So if we run that, and then we do map underscore block, run that, you'll see that now our lines are blue. So if we do map block wide, I'm going to just copy this here, copy that to there. Now we can also do line WD, and I'm going to set that to 3 just to really show you, sort of exaggerate the line width for a second. And so we run that, and then we will map underscore block, we run that. Ooh. That block wide, otherwise we're not going to see the difference. You'll see that the lines now are much thicker. So that's what line width does. And you can obviously make this any number you want. The bigger, the wider the line will be. Alright, so let's go ahead and let's do one more. Let's do map block, and instead of line width equal, let's set that. Get rid of that, we'll put that back to default. Line TY. I'm going to use 3. Actually, I shouldn't use 3 because 3 is what we just used before. I don't want to confuse you. We'll do 5. So what the line type of 5 is it's going to be a combination of dots and dashes. You know, actually, let's go ahead and let's make it a little bit thicker so you can actually see a little bit clearer. So we'll call this dash. And then we ran it. We didn't get any errors. Let's go ahead and run this now so you can see it. And you'll see now that we have, at least on the outer ones, you can see it a lot more clearly. On the inner ones, they're a little short, so it's harder to see. But you can see that we have dashes. And if I were to make this a, I think 4 is the dotted one. I may be misremembering it. 4 is the one that includes the dots. So you can see it even clearer here. And again, I encourage you to go to this website, and there will be a link to this in the description, that has access to all of the different numbers and what they mean. So that's color, line width, and line type. I want to do alpha a little bit differently. I want to stick with the blocks, but I want to make it with fill so that you can really see what alpha does. So I'm actually going to copy this so I don't misspell blocks again. And we're going to do a tm underscore fill, which is going to give us just the filled polygons. It's not going to have the borders. And you'll see the contextual pop-up here says that we have access to call and alpha. And what I want to do is I want to set the call to green, I guess, why not? And then I want to, with a comma separating them, I want to set the alpha. So again, with alpha, 0 is completely transparent and 1 is completely filled. So actually, let's go ahead, before we do that, let's just run this the first time. Let's change this to no alpha first. And let's run this. Map block no alpha. And if we trans that, you'll see that we get this nice, really bright, vibrant green color. And because we don't have the borders, it's just a solid mass of color. So let's go ahead and let's copy these down here. And let's remove the no, because we're going to actually use alpha. So we're going to keep the color as green. But what happens if I set the alpha parameter to say 0.5? So this is 50%. If we run that, then we run that. Now this might be a little hard to see depending on your screen, but hopefully you can see that this is much paler, and that's because it's actually semi-transparent. I think we might be able to get away with a better example here if we do something like this. I'm going to use the tracks data, but I have to set the projection for tracks because for some reason the tracks data set doesn't come in with a projection, even though it should. So I'm going to copy the projection for tracks. And then to show you that this works, what I want to do is I want to set up this. I want to put before, so underneath, so this would be drawn first. I want to put the tracks. And I want to use tm underscore border. And I want to put the borders, I'm going to set them equal to, I think black should be fine. The default for this should be fine. What I want to get across here is that in this way that we've set this up, if I were to remove the alpha, just to show you what I'm talking about, right, if I were to map, we'll call this multi-alpha so that we don't get confused. So if I run that, and then I run this, all right, I've taken away the alpha, and you can see sort of along the edges where it wants to display the lines, but that's just an artifact, right? If you zoomed in, they wouldn't be there. Right, but you can tell that we've completely covered up any semblance of the borders because this fill argument and the blocks came after. But let's see what happens now when we add a alpha type of say 0.25. So the closer to 0 we get, the more transparent the layer will become. So if we run this and then we run this, you'll see now that we can see the lines underneath. Right? We haven't changed the order here, right? It still has the blocks with the fill on top, but because we've made it almost completely transparent, you can see the lines start to show up underneath it. And the reason that you can tell they're underneath it is because they have that sort of greenish tint to the line work, and that's because they're being colored by this transparency. So hopefully that made sense. The last two that I want to walk through are the points. So I want to just do quickly map bergs equals tm underscore shape. And we're going to do shape equals bergs female. Okay. And so this is going to be our point data set. And I want to start off by talking about size. So we're going to tm underscore dots, and you'll see that we have access to the call parameter, the size parameter, and the shape parameter. Now I think it's important here to note with the color that only certain shapes can be colored. And I encourage you to go back to that website that I talked about earlier and I talked about in the previous video to just look and confirm that the shape that you're using can actually hold a color. So 16, which is the default, can hold a color. So if we did use color, we wouldn't have an issue there. But there are some shapes that will not hold a color. So just please be aware of that. So anyway, what we can do here is we can change the size. What I want to do is I want to actually do a default just to show you. Actually, I want to redo this because I want to recomplete that because I want to show you something. Where it says size, you'll see that size equals 0.02. And I don't know if I mentioned this in the previous video or not, but size is always relative to that standard 1 unit default. And you'll see that the default for TM dots is substantially less than that 1 unit default. So if I run this and then I plot it, you'll see these dots are really small. Right? And so your first instinct may be, well, I want my dots to be double the size of that. Right? I want my dots to be twice as big. That's the perfect size. I want to be twice as big. So you may be tempted to do size equals 2. Well, you have to realize that the default size for dots, for TM dots, is not 1. So this is not going to be double the size of the dots as they appear in the default. It's going to be double the size of the 1 unit default, and they're going to be astronomically larger. So if we actually, let's run this from up here. See how they're huge now. And that's because the default for TM dots was not actually size 1, it was size 0.02. So if we do this and we do size 1, and we run this, this is what the default size 1 would appear as. That's the default size 1. This is what everything is relative to. So the actual TM dots is using a size of 0.02. So just kind of keep that in mind, that the default when we say size is always based on size 1, but the sort of built-in parameter for TM dots is size 0.02. So keep that in mind. And finally, I want to talk about shape. So let's do map underscore bergs underscore shape. And we're going to copy this here. And I'm going to go with a size of 0.5 just to sort of make sure that we can see the differences here. So by default we use size 16, which is a shape 16, which is this sort of filled in circle, and by default the color is black. So let's go ahead and let's do a shape of, let's do 3. Just show you what that looks like. Run that. You'll see now that we have these black crosses. So that's what the integer 3 refers to in that sort of shape table, which again, I encourage you to go to this website right here, link in the description, to sort of look through and see what the different numbers mean. I've already kind of went through a little bit of them in the previous videos. So hopefully this made sense. I know there's a lot, but again, if you ever get lost, just sort of remember that these 6 parameters tend to show up and they do the same thing in every single function. So you're never going to have line width doing something different for borders. It's going to do the same thing for borders that it does for lines. So if you see LWD, it's going to be referring to the same thing pretty much in every single one of these functions. So if you just kind of remember what these 6 functions are, kind of what they do, remember kind of what the defaults are based on, and then remember these tables if you get into trouble, you should be in pretty good shape. So again, if any of this was confusing, I encourage you to go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.